In the previous video, the title was infinite limits. And what that meant was we were talking about limits where as we approach some value, some x value, the value of the expression was infinite. It was growing larger and larger. This lesson is a little bit different. In this lesson, I want to talk about things like the limit as x approaches negative infinity of some expression, or the limit as x approaches positive infinity of some expression. So this lesson is about limits at infinity. To me, a lot of these problems just kind of require common sense. Like I sort of want to show you a couple of basic problems to give you a sense for how these are going to work, right? So suppose I asked you, what's the limit as x approaches infinity of 5,000 divided by x, right? What effectively does this problem mean? Well, I've said that for every problem, we should be, attempting to evaluate this expression for this value. In other words, it means try plugging in infinity and sort of mentally think, what does 5,000 divided by infinity mean? Like go back to your grade school example of the pizzas, right? This means you have 5,000 pizzas and you're sharing them with how many people? With literally infinitely many people. You have 5,000 pizzas, but you have enough people, you have a line of people that want pizza that will never end. Right? How much pizza do you effectively get to give to every person? You effectively get to give zero. You give one pizza molecule, and even then you'd run out of molecules of pizza, right? In this case, it's going to be zero. I really see a lot of these problems as like battles. This is the battle between 5,000 and x. And x is going towards infinity. Dude, infinity wins, right? 5,000 divided by infinity, we're done, right? On the other hand, what if we were looking at something like the limit as x approaches negative infinity of x divided by 5,000. Right? What does this now mean? So this means I have infinitely many pizzas and I'm sharing them among 5,000 people. Dude, if you're never going to run out of pizzas, you can effectively give infinitely many pizzas to everybody. This will be negative infinity. Because again, in the battle between infinity and 5,000, infinity is way, way, way bigger than 5,000 is. Right? So these are sort of two guiding ideas for how we deal with limits at infinity. And I guess the point that I wanted to get across during this introductory slide is that lots of times when you're doing these problems, you're kind of just thinking, as I'm plugging in infinity, can I tell what the function is doing? Can I see whether it's getting super, super small or whether the values are getting very, very large? That's sort of the thought that you need to be considering. So the strategy that we're going to use here is actually something that you probably saw in math analysis, although I think I explain it slightly differently, right? What I want you to do in these problems when you have an expression like this is divide both the numerator and the denominator by the highest power of x in the denominator, right? I think last year you guys just divided by the highest power of x. For me, I really feel like it makes more sense to do it by the highest power of x that's in the denominator. And then you'll, quote-unquote, evaluate the expression using infinity or negative infinity. Which means try plugging infinity, try plugging in negative infinity, and try and think through what's happening, like what this value is approaching. So here's my first example, right? I want us to evaluate this limit. Right? So using the strategy that we mentioned on the previous page, this limit is approaching infinity, I'll divide everything in the problem, everything in the numerator and the denominator, by the highest power of x in the denominator. So I'm going to divide through by x squared. When I do that, I'll end up with the limit as x approaches infinity of 2 over x squared plus 3 minus x cubed over x squared over 5x squared over x squared minus 3x over x squared. And I could have simplified that as I went along. In fact, it looks like I sort of already did that here. We'll just take one more step to simplify this. The limit as x approaches infinity. So this is still 2 over x squared. This is still 3. This is minus x. On the bottom, I'll have 5 minus 3 over x. And this is where we sort of go through and we start selectively evaluating as x approaches infinity. So as x approaches infinity, this term here is going to turn into 0. Right? This term here is going to turn into 0. And so when I turn those both into 0, sort of what I have left is I have 3 minus x in the numerator and 5 in the denominator. At this point, we have to sort of pause and just sort of think, okay, so now what happens when I plug in infinity here? What happens when I plug in a gargantuan number here? Well, pause the video and think about that for a second. What I hope you'll find is that in the numerator, you're effectively going to get, like negative infinity, I guess minus 3, whatever, and then divided by 5. That 5 means nothing to the negative infinity, right? Your final answer here is that this limit is approaching negative infinity. So here we have another similar example. So pause the video, try this one out, and see what you end up with. So I'm going to have the limit as x approaches negative infinity. Right? This time I'm going to divide by the highest power of x in the denominator, that's x squared, and I'm going to skip some steps here. This is going to give me 1 plus 5 over x squared over negative 2 plus 17 over x. At this point we start thinking about evaluating for x being negative infinity. As I plug in a huge value, both this turns into 0 and this turns into 0. Because you've got an infinity in the denominator, and 5 and 17 just have nowhere near the strength necessary to stand up to that. Right? All I have left is negative 1 over 2. There aren't even any x's left, which means I don't need the limit anymore. This limit approaches negative 1/2. That is the limit that we have. Here's another one for us, and this one is a little bit sneakier. So pause the video, sort of see where your thoughts take you on this one. Maybe even just take one step and then see what I do. So in this case, there's an x squared in the denominator. So the natural thing to do seems to be to divide the numerator and the denominator by x squared. Right? So in the numerator, I'm going to end up with x squared sine x over x squared all over 1 plus 3 over x squared. And now if we sort of think about this one, this thing on the bottom is obvious. 3 over x squared definitely turns into 0. Right? And then the denominator, this is just 1, so really what I have left is just the limit as x approaches infinity of x squared sine x over x squared. I'm sorry, it wasn't x squared, that was a mistake. Sorry, this thing in the numerator should have just been x, so that was a mistake back there. So down here, this should also just be x. So I'll have to cross out that squared up there. So now, how can I simplify this? Right? I can simplify this to be the limit as x approaches infinity of sine x over x. Now this is weird, but it's something we're going to need to think about, and then I hope it's something that you guys will be able to sort of process and understand. As x approaches infinity, what's happening in the numerator? And you're going to need some brain space for this, so don't just run away screaming and don't just skip this part. Like, think about this. As I plug in larger and larger and larger and larger and larger numbers, what happens with sine x? Like, what's the sine of 5,000? What's the sine of 50,000? What's the sine of 500,000? What's the sine of 5 million? They're all kind of random. But what's important is that these things in the numerator are all somewhere between negative 1 and 1, which means they're small. I have something small and changing on the top, and on the bottom, I have like crazy infinity. It's sort of like saying, I have somewhere between negative 1 and 1 pizzas shared by infinitely many people. At the end of the day, everybody's going to still end up with 0. This limit is 0 because I have something small divided by a huge value. Right? Sometimes these limit problems aren't perfectly straightforward, and this is one of the cases where that happens. So I have one last example that also involves a little bit of trig. So I'd really like you guys to pause the video, try this one, and I'm really hoping that you'll come up with an answer on your own that you're happy with. So I'm going to divide the top and bottom by x, because that's the highest power of x in the denominator. I'm going to end up with 1 minus sine x over 2 plus 3 over x. Right? Once we've done that step, we think about evaluating, plugging in, whoops, I missed my negative. We think about plugging in negative infinity. Right? We definitely know down here, when we attempt to plug in negative infinity, this thing is going to turn into 0. Right? Now what about this thing up here? As we approach infinity, what happens to that? Well, as I plug in infinity, remember the top is sort of changing back and forth, and the bottom is getting large, so this also turns into 0. And so it looks like when I do that, all I have left is my 1 over 2, and so this limit approaches 1 over 2. Right? So that's the strategy that we use here. We definitely divide by the highest power of x in the denominator, but once that's done, there's usually some thought that has to be done in terms of figuring out what this limit's going to be.